In this video, I am going to find the Maclaurin series expansion for e to the power negative x. Maclaurin series, this is how it's written. F of x is equal to summation n is equal to 0 to infinity nth derivative of f evaluated at 0 divided by n factorial times x to the power n. If you were to write it out, 0th derivative is just f of 0, right? Then f prime of 0 divided by 1 factorial times x, f double prime of 0 divided by 2 factorial times x square plus f triple prime of 0 divided by 3 factorial times x cube plus dot dot dot. Okay, so let's go ahead and find the values of these coefficients. F of 0, so my f of x is equal to e to the power negative x. That tells me that f of 0 or f evaluated at x equal to 0 is going to be just 1. Then f prime of x, okay, is nothing but negative e to the power negative x, and if you evaluate it at 0, f prime of 0 is going to be negative 1. Similarly, f double prime of 0 or f double prime of x first is going to be just positive e to the power negative x, and then f double prime of 0 is going to be positive 1. And you can see it alternates between positive 1 and negative 1. If you're taking odd number of derivatives, it's going to be negative. If you're taking even number of derivatives, it's going to be positive. So let me go ahead and plug in these values into the Maclaurin series. So my f of x is equal to e to the power negative x is going to be f of 0, the first term, which is 1, plus f prime of 0. F prime of 0 is negative 1. So it's going to be negative 1 over 1 factorial times x, plus f double prime of 0, which is positive 1 over 2 factorial times x square, plus f triple prime, which is going to be negative 1 if you did it. Okay, f triple prime of 0 divided by 3 factorial times x cube plus fourth derivative evaluated at 0 is going to be 1 divided by 4 factorial times x to the power 4 minus plus negative 1 is the fifth derivative evaluated at 0 divided by 5 factorial times x to the power 5 plus dot dot dot. And as you can see, this becomes nothing but very simple. 1 minus x over 1 factorial plus x square over 2 factorial minus x cube over 3 factorial plus x to the power 4 over 4 factorial. Oh, okay, no, I got it right. I thought for a second I made a mistake. Then minus x to the power 5 over 5 factorial plus dot dot dot, plus nth term will be negative 1 to the power n times x to the power n over n factorial, and it keeps going. Now you could put it in a compact format. E to the power negative x is going to be equal to summation n is equal to 0 to infinity, okay, negative 1 to the power n times x to the power n divided by n factorial. So this is how you'd find the Maclaurin series for a given function. And in this particular case, we found it for e to the power negative x. I hope that this discussion was helpful. Thank you very much.